Hi and a very good day to Prof. Ng. My name is Nadiatul Asma and I will be presenting on Introduction of Secondary Ion Mass Spectrometry, SIMS. What is SIMS? SIMS is a sensitive surface analysis technique that can be used to quantify all the elements in the surface layers of a solid sample. In addition, it can provide isotopic and molecular information. SIMS is typically applied to inorganic solid materials such as semiconductors. Accurate elemental quantification is achieved by comparison against well-calibrated standards. That's all from me. I will pass the presentation to Darhshernn. Thank you.
Thank you, Nadiatul. Hi everyone, I'm Darhshernn and I will begin the working principles section by discussing the primary ion sources. Typical SIMS instruments use either a duoplasmatron or a surface ionization primary ion source or both. Basically, it's user selected. The duoplasmatron increases the yield of electropositive elements while the cesium surface ionization source enhances the yield of electronegative elements. Primary ions are actually extracted from the sources and are passed through the sample through the primary ion column. The column usually contains a primary beam mass filter that transmits only ions with a specified mass to charge ratio. Besides that, the electrostatic lenses and the apertures control the intensity and the width of the primary ion beam, while the electrostatic deflectors steer the primary beam in a raster pattern onto the sample. Secondary ions are extracted from the samples as they are produced. The secondary ions accelerate towards the ground plate of an electrostatic lens. The first lens is called the immersion or ion extraction lens. The second transfer lenses focus the ion beam onto the mass spectrometer entrance slits or aperture. The combination of a magnetic and electrostatic sector produces a double focusing instrument. As this secondary ion passes into the electrostatic energy analyzer, the lower energy ions are more strongly deflected than the high energy ions. As an ion beam passes through a magnetic field, the ions are deflected by the magnetic field. The entrance and exit slits can be arranged for the clearness of separation. A magnetic analyzer in combination with the energy analyzer can attain a high mass resolution. These are the example schematics of mass analyzers which can replace the traditional double focusing magnetic sector. That's all from me. Next, I'll pass the floor to Suraiya. Thank you.
Thank you, Darhshernn. Hi everyone, I am Suraiya and I will present on detector, display mode and dynamic and static SIMS. Electron multiplier consists of diodes. When the ion strikes the diodes, it produces secondary electrons. The Faraday cup detector consists of a hollow conducting electrode connected to ground via a high resistance. The ions hitting the collector cause a flow of electrons from ground through the resistor. For the image plates, an ion passing down a channel hits the inner channel wall and produces secondary electrons. Electron multiplier is the most sensitive detector which converts more than 5 times 10 power of 6 scan per second. Mass spectra sample the secondary ions in a preselected mass range by continuously monitoring the ion signal while scanning a range of mass to charge ratio values. The mass analyzer can be either a magnetic sector or quadrupole. Ion imaging shows secondary ion intensity per pixel as a function of location on sample surface. Dynamic SIMS mode investigates bulk composition and in-depth distribution of trace element, with a depth resolution from sub-nanometer to tens of nanometer. Static SIMS are focused solely on the first top monolayer, mostly for molecular characterization. This table shows the comparison between dynamic and static SIMS. Factors affecting depth resolution in dynamic SIMS are crater edge rejection, ion beam mixing, and surface roughening. Common modes of analysis are bulk analysis and mass scan mode using static SIMS, depth profiling mode using dynamic SIMS, and imaging mode. That's all from me and I will pass the presentation to Sami. Thank you.
Hello everyone, as you can see here, there are several strengths of using SIMS, which are the most important is simple sample preparation and high depth resolution. As you can see, SIMS has many advantages and disadvantages. The most important is probably that SIMS can identify all elements. However, the most important disadvantage is strong matrix interferences. There are many applications using SIMS instrument as stated in this slide. The most important is in nanomaterial science and corrosion science. We can see here the author was studying the composition and the substructure of nanoparticles using in animal studies to explore lung inflammatory response to inhalation of insoluble particles. The pure iridium and mixed carbon iridium nanoparticles were spark generated by using iridium and carbon electrolyte, and SIMS with 34 keV argon primary ion relevant a wide range of mixed iron, carbon, nitrogen, and oxygen, and hydrogen secondary fragment ion. Finally, the outcome by SIMS analysis, which is SIMS are used to characterize the chemical composition of nanoparticles prepared under different conditions. Also, SIMS analysis generated very complex mass spectrometric information. The result may be considered significant for animal studies on health effect due to inhaled nanoparticles. Also, author claimed that the study has shown that particle analysis be an advanced surface analytical technique like SIMS is needed if one wants to characterize the product of spark discharge particle formation as completely as possible. Thank you.
Lastly, I will be presenting about frequently asked questions regarding SIMS. Presented are some of the commonly asked questions. The first question is, what is this analysis commonly used for? The answer is that SIMS is used for elemental and isotopic characterization of surface layers in solid materials. Next, for the second question, what are the limitations of SIMS? First limitation is, because both atomic and molecular species are produced during sputtering of the samples, not all elements in all substrates can be analyzed quantitatively. And second limitation is that SIMS instrumentation tends to be very expensive. The third question is, what kind of samples can be analyzed with SIMS? And the answer to the question is that it can be used for solid samples that can tolerate being placed in a vacuum. This is because charged particle beams require a vacuum environment, and the samples used are typically inorganic. Moving on to the fourth question, which is, what is the differences between time of flight SIMS and SIMS? The answer is, both are the same in terms of mass analysis of secondary ions, but differ in primary ion beam type, equipment, and the information obtained. And the last question is, what are two advantages of SIMS? The answer is that SIMS consumes very little sample that is essentially non-destructive. Another advantage is SIMS is highly sensitive, where it can analyze samples with a low concentration down to ppb levels. That's all from our group. Thank you.